Hello, year 11. Uh, Sorry I'm not in today, but you're still going to do some physics paper 2 revision. Before we start, can you make sure that you have the correct paper in front of you? So it should look like this at the top. Foundation paper, physics paper 2F from the 14th of June 2024. Make sure you also have a whiteboard and a whiteboard pen. And please pause the video to make sure that all the students have all the equipment needed. Okay, let's begin. On your mini whiteboard, can you answer this question? So what is the unit of a force? How are forces measured? And what's the name of forces A, B, C, D, and E? You're going to have about 3 minutes to answer this question. Please pause the video. All right, welcome back. So you have the unit of a force are the newtons. And the forces are measured using a Newton meter. And the forces are, so B is a force going downwards. That's called the weight. Caused by gravity on an object with a mass. C is the thrust, okay, caused by the engine, caused the boat to move forward. D is called upthrust, is the force exerted by the water on the boat. E is probably going to be water resistance or drag. A is going to be air resistance. Yes, hopefully you got all this answer correct. You need to know all these forces. Very quickly, this is the forces applied to a skydiver when they jump. So at first, when they jump from the plane, they're not moving downwards to start with. So only the weight is applied to the skydiver. They're going to accelerate downwards. When they accelerate downwards, they're moving faster and faster. The air resistance is going to increase. Okay, but you're still going to have an overall downward force. So the skydiver is going to keep on accelerating downwards, moving faster and faster. By doing so, the air resistance is also going to increase until a certain point where the air resistance is exactly the same as the weight. At that point, we say that the forces are balanced, and when forces are balanced, an object stopped accelerating. So the skydiver is going to reach speed that's going to stay constant for a while, and that is called the terminal velocity. Then they're going to open their parachute, and that's going to increase the air resistance a lot, which means that the overall force is going to be upwards. The skydiver is going to slow down. Because they're slowing down, the air resistance is going to decrease until the air resistance and the weight are equal. If they're equal, the skydiver is not accelerating anymore, and they're going to keep on moving downwards at a constant speed, which is a lot slower than before, which is going to probably save their lives. Okay, so you need to remember this, how forces are changing over time. The only one that doesn't change is the weight, because the weight is caused by the mass and the mass is constant. So the weight is constant, but the air resistance is going to change. Okay, now what I would like you to do is take 5 minutes to answer question 1 and 2 of the paper. So please pause the video and take 5 minutes to answer this question. Okay, welcome back. Please get your green pen. We're going to go through question 1 and 2 together. So figure 1 shows a skydiver jumping from an airplane. The skydiver is accelerating downwards. That means it's moving faster and faster. Which force causes the skydiver to accelerate? So it's the force going downwards. It's called the gravitational force or weight. Okay, not the electromagnetic force, not the magnetic force. The second one was correct. Which force increases as the skydiver accelerate? So because they're going faster and faster, air resistance is going to increase. Okay, not the normal contact force or the tension. The tension is caused by, for example, a piece of string lifting an object up. That's the tension. And the normal contact force is if you put an object on the table, is the force applied by the table on the object. Next one, figure 2 shows the two forces acting on the skydiver a few seconds after jumping from the airplane. So you can see an arrow going down, which is the weight, and an arrow going up, which is the air resistance. Calculate the resultant force acting on the skydiver. Because they're going in opposite direction, we're going to have to do 600 minus 150 to find the resultant force, which is 450 Newton. Okay, make sure you show your work just in case. Next question. Eventually, the skydiver stops accelerating and falls at a constant velocity. What is the resultant force acting on the skydiver when falling at a constant velocity? So if they're moving at constant velocity, it means they're not accelerating. If they're not accelerating, it means no force is applied to the skydiver, or that all the forces applied to it are balanced. Therefore, the resultant force is 0 Newton. Okay, so if an object is moving and the overall force is applied to it is 0 Newton, the object keeps moving in the same direction at the same speed. What name is given to the constant velocity of the skydiver? It's called the terminal velocity. Figure 3 shows a velocity time graph for the skydiver. So time is on the x-axis and the velocity on the y-axis in meters per second. How many seconds did the skydiver accelerate for? So you can see the change in speed, okay? And if you look carefully, for the first 20 seconds, the skydiver is moving faster and faster. It accelerates a lot more at the beginning than at the end, okay? But it's still accelerating up to 20. And it stops accelerating after 20 seconds, okay, where the velocity stays constant. What was the constant velocity of the skydiver? So the horizontal line is reached at 46 meters per second. If you see, each square is 5 meters per second, and we're one little square on top of the big square, so 46 meters per second. After opening a parachute, the skydiver fell at a constant speed of 3.6 meters per second for 25 seconds. Calculate the distance traveled by the skydiver during this time using the equation distance travel equals speed times time. So remember, you have some question like this. You have to make sure you have the right unit. And the unit for speed in physics is meters per second. The unit for time is seconds. We have all the good things here. We don't have to do any conversion. So the distance equals 3.6, which is the speed in meters per second, times 25, which is the time in seconds, and that is 90 meters. Question 2. Shows a person using a Newton meter to measure the weight of the suitcase. So remember, the weight is a force. Okay, it changes depending on gravity, and it depends on the mass, but the mass stays constant. How does the force on the suitcase compare with the force on the Newton meter? So the Newton meter is pulling the suitcase upwards, and the suitcase is pulling the Newton meter downwards. Okay, so they work in opposite direction, but they have the exact same size. Which sentence describes the direction in which the pair of forces act? They act in opposite direction. Okay, same as if you were pushing a wall, you're pushing the wall is also pushing you. So the magnitude is the same, but the direction is the opposite. And 2.3, what is the weight of the suitcase shown on the Newton meter in figure 4? So if you look carefully, it's somewhere between 180 and 200. Each little mark is 2 Newton. So this one here is 196 Newton. And I forgot the N, so make sure you write down 196 capital N for newtons. 2.4, calculate the mass of the suitcase. The gravitational field strength is 9.8 Newton per kilogram. And we have to use our answer from question 2.3, which was 196. So the mass equal the weight, 196 Newton, divided by 9.8 Newton per kilogram. And that's going to give us an answer in kilogram, which is 20 kilograms. 2.5, the suitcase is loaded into an airplane. The airplane takes off and its height above the ground increases. The airplane then flies at a constant height. Figure 5 shows how the gravitational field strength in the airplane varies for the first 25 minutes of the flight. Describe how the weight of the suitcase will change during the first 25 minutes of the flight. So if you look at the graph showing the gravitational field strength, in the first 15 minutes, the gravitational field strength decreases. Okay, the higher you get in the sky, the lower the gravity. And between 15 and 25 minutes, it stays constant. That means that the suitcase is going to be less attracted to the Earth while it's going up. So the weight will decrease as the gravitational field strength decreases for the first 20 minutes. And from 15 minutes to 25 minutes, the weight will stay constant because the gravitational field strength stays constant. So for the 3 marks, you have to tell me this. The weight first decrease or you have to mention 15 minutes, and then the weight stay constant. Okay, we have time for this bit. So quickly, revision on waves. On the mini whiteboard, what are the 2 types of waves? What do waves carry? And you have to label 1, 2, 3, and 4. If you could take 3 minutes, so pause the video for 3 minutes and write down all these answers on your mini whiteboard, please. All right, welcome back. So the 2 types of waves are transverse and longitudinal. A transverse wave, it's like the wave we have in the water or light, etc. The oscillation is perpendicular to the direction of the wave. Okay, so the wave is going from left to right, but the water particles, for example, are going to move up and down, perpendicular to it. A longitudinal wave, the oscillation are parallel to the direction of the wave. So, for example, sound is an example of a longitudinal wave. The particles of air are going to vibrate from left to right, right to left, and the wave is going to travel from left to right. Okay, so parallel to the movement. So the 2 types, longitudinal and transverse. If we look at waves carry energy. They don't carry matter, they only carry energy. So sound carry energy, light carry energy, etc., etc. For the label, number 1, the height of the wave, or distance between the middle and the top, is called the amplitude. Number 2, which is the top of the wave, is called the crest. Number 3 is the distance between 2 identical points or on successive waves, and that's called the wavelength. And number 4 is the bottom of the wave, and it's called trough, T-R-O-U-G-H. So you need to know these keywords, and you need to know the difference between longitudinal and transverse. Okay, you're going to take 5 minutes to answer question 3 of the paper. À l'attaque. Okay, welcome back. Get your green pen. We're going to go through question 3 together. So, figure 6 shows an electronic whistle used by a referee in a football match. What is transferred by the sound waves as they travel through the air? So, because sound is waves, it's going to transfer energy, not mass, not temperature, energy. All the waves do that. 3.2. What is a typical value for the speed of sound in air? You have to know this one is 330 meters per second. Okay, you have to know this value. You also need to know the value for the speed of light, which is 300 million meters per second, or 3 times 10 to the power of 8 meters per second. So this one here was 330 meters per second. The whistle can emit 2 different sound waves, A and B. We have to compare with A and wave B. So wave A has a greater frequency than wave B, okay? The waves are a lot closer to each other, which means you have more waves passing by per second in A than in B. Wave A has the same amplitude, it has the same height as wave B. And remember, for frequency is measured in hertz, amplitude not really measured in anything, but the loudness is measured in decibel. So both sound have the same loudness, but they don't have the same pitch because they don't have the same frequency. For the next question, wave A has a frequency of 4 kilohertz. Which of the following is the same as 4 kilohertz? Remember, 1 kilo is 1,000, so 4 kilohertz is 4,000 hertz. Okay, you take the value in kilohertz and you multiply it by 1,000 to get it in hertz. Use your answer from question 3.4 and the equation to calculate the period. So 1 divided by 4,000 is 2.5 times 10 to the power of minus 4 seconds, or 0.00025 seconds. When sound waves travel through air, they create areas of rarefaction and compression. Okay, I'm going to show you very quickly again from the first wave that we saw here. So the part where the particles are really close to each other, that's compression. The part where the particles are really far away from each other is called rarefaction. Okay, this is it for the first part of this lesson. Please open the second part for question 4. Let's go.